this video, I'm going to be describing how to evaluate limits and more specifically left and right limits. So the general form for limits is the limit of f of x is equal to L as x approaches a. And for each term of that, the lim, LIM, is abbreviation for limit. Arrow to a is as x approaches the value a. F of x is the function, and L is the limit of the function. So for left and right limits, x approaches a with a negative sign. On the right side of the a is x approaching a from the left. X approaching a with a positive sign is x approaches a from the right. And then x approaching infinity is x approaches infinity. And x approaching negative infinity is x approaches negative infinity. So for our first example, to evaluate left and right limits, we're going to look at a graph right here and evaluate the left, right, and both the limits combined, as well as the function itself. So as we can see in the graph, we have two lines with closed circles and one closed circle right here. So to evaluate this, we look as limit f of x as x approaches 2 from the left. So we look and see as x approaches 2 from the left, we get 2. Or, my fault, we get 3. Because when you're doing this, you are looking for the value of f of x, which is the y, when it's at the x value 2. So at the x value 2 from the left, we get 3. And the x as the limit of f of x as x approaches 2 from the right, we go from this side, push from the right, we get negative 4. Now, when you're looking at limits and you are evaluating left and right, and you come to one that has no positive or negative, it is asking if the limit exists, pretty much. So you can see here that the left one is 3, the right is negative 4. And these two are different. And because of this, the limit does not exist at 2, because the left and the right limits do not match. So this will be D and E. Does not exist. To evaluate the function f of 2, we look for the closed circle, which right here is 1. So for the next example, we're going to look at another graph. Now this one looks quite different, as we can already see that the limit is, or the graph is connected, and so we can already agree or assume that the limit of x approaching 2 is going to exist. But to make sure that, we look as x approaches 2 from the left, go here, we find that it is 2, and x approaches 2 from the right, is also going to be 2. So in this graph, the left and the right limits are the same. So this right here, as x approaches 2, is going to exist at 2. So when you're looking at evaluating left and right limits, if the left and the right limit are the same, then this is going to be true. If not, it's not going to exist. The limit at the x value, if it's different from the left and the right, will not exist if there's a hole, like in this function, or any other obscurity. And to finish this question off, f at 2, we're going to look for that closed circle, but there is no closed, only the open, so f of 2 does not exist. So when evaluating left and right limits, we are looking for the left and the right equaling each other. And when evaluating the function at that x value, we are looking for a closed circle. Thank you guys for watching.